Welcome. This is actually a chapter on wave. We are going to tackle you run with me through theoretical parts of wave only, the theory. About 60 questions here plus. The first question: a string is sustaining a stationary wave when write down. Uh, con- uh, right stationary wave. Then beneath under right, two pro- two progressive waves must be involved. Second, right again. The waves must move in opposite direction. The wave must move in opposite direction. And number three, the wave must have equal amplitude. Number four, the wave must have equal frequency. And lastly, the wave must have equal wavelength. The wave must have equal wavelength. And lastly, right, stationary wave is also called standing wave. Stationary wave is also called standing wave. Number two, which of the following types of wave cannot travel through a vacuum? Sound wave doesn't travel through a vacuum. Sound wave doesn't travel through a vacuum, an empty space. The reason why you can hear me is actually because there's an air. As I speak, there's an air, vibration of air that would get into the mic I'm using, or else you can't hear me. Okay, so sound wave doesn't travel to a vacuum. A vacuum means an empty space. Number four, calculation. Number five, any line or section through an advancing wave in which all the particles are in the same phase is called the wave front, right? It's called light wave, radio wave. It's number five. I think there's a. Let's see number four first. For the wave motion represented in the figure, the wavelength is okay. So it will be the wavelength too. Option D. From this top here, see this cursor. To get a wave, you will get one up like this, like this, then this other place you get. So one up, one down, one this from here go like this is one loop, come like this is another loop. You get. Then if you from this up here to this up here, you get S. So S represents a wavelength, one wavelength. So number four is option D. Number five is supposed to be wave front, but the options are wrong. Number six, the following types of wave are all transverse wave except right. A transverse wave travels perpendicularly to the direction of its vibration, while a while a longitudinal wave travels parallel to the direction of its vibration. Parallel to the direction of its vibration. So number one, the following types of wave are all transverse wave except raise in temperature of the unit mass of a substance by this. There's, I think this number six here is supposed to be among those ones for temperature. There's a mistake, and these options for number five is supposed to be here for number six. I think you see most times some students that don't know now, they might just cram this, and for them, I've studied. Not like that. So the question: which of the following types of wave are all transverse wave? Transverse wave. Okay. We are going to see similar questions subsequently, and I would give an example of transverse wave. Okay. Remember, from this up here to this up here now, one wavelength. 8. The combination of sound wave with different frequency is known as superposition. Now, right. Interference is a superposition of two identical waves traveling in the same direction. Some persons might go and say it is interference. No, it's superposition. I've given you what's the meaning of interference. Jot it down, please. 9. Ripples on water are similar to light wave in that they both can be refracted and diffracted. Number 9, option E. Longitudinal wave do not exhibit polarization. They can't be polarized. Waves that travel in a straight line, you cannot cut them into parts. So example, if you have light shining in a room, because there's wall in a room on its own, it will naturally help separate the light from shining. In fact, let's use a curtain. The room now, the bulb is towards one side. If you put curtain up down, the other side of the room will become dark. That's the concept of polarization. But if the person is on the other side, if he's talking, if you're on this other side, you can hear. You can hear. Even if they lower their voice, most of you today you whisper on. You eavesdrop on people. Go put ear for door, they listen. So they press better conk for your head. Let's go. So radio wave that one has to be calculation. 12 calculation, 13, 14, 15, 16, 17. Which of the following property are common to all waves? Which of the following property are common to all waves? The property that is common to all waves here is diffraction, refraction, and interference. Option D. 18, 19, 20, 21. Okay. A wave disturbance traveling in air enters a medium in which its velocity is less than that of air. Which of the following statements is true about the wave in the medium? When wave travel through a medium, right? The frequency of the wave is unaltered, while the wavelength would decrease. Wavelength can change, but the frequency is always constant. Okay. The frequency is also always constant. 21 is option C. 22. Which of the following is true of light and sound wave? They both transmit energy. Option A. 23. 24. Which of the following characteristics of wave is used in the measurement of depth of a sea? The measurement of depth of a sea. Which of the following is used? Reflection is used. Reflection. 25. Which of the following wave can propagate through a vacuum? Through a vacuum. Anything that has to do with sound will not. Acoustic has to do with sound. Sound wave, ultrasonic, all those ones will not. Is infrared. 25 is D. Infrared are part of electromagnetic spectrum. They're like light. Light wave can travel through a vacuum, but sound waves cannot travel through a vacuum. Calculations. 28. Which of the following is an exclusive property of transverse wave? Polarization. Transverse waves now, like light wave, polarization. 28 is option D. 29, 30. The difference between sound wave and light wave is that sound waves are longitudinal, while light waves are light wave. 30 is option B. Sound wave requires a medium to travel, while light wave do not. This is like a major one. Ripples on water and light waves are similar because both have what? 31 can be refracted and diffracted. 31 is option B. 32. The diagram below shows two waves from P and Q at a particular instant of time. The two waves will interfere. They will interfere constructively to produce a wave of a larger amplitude. Option C. 33 is not it. 34, 35. Which of the conditions above are necessary to produce interference? Interference fringes. Which of the following are necessary to produce interference fringes? 35 is same frequency and same wavelength. Option D. Same frequency and same wavelength. 36. One end of a long wire is fixed while the vibrator is attached to the other end. When the vibrator is energized, the types of wave generated in the wire is. 36. The wave are stationary and transverse. The stationary and transverse. Stationary and transverse. I want us to write this down. The wave in a wire or string, string, is mechanical and transverse wave. Mechanical and transverse wave. But in this case, you get your stationary and transverse. Option A. A plain sound, that's option A, that one. A plain sound wave of, calculation. Vibration in a straight string cannot be polarized because it is longitudinal. 39 cannot polarize it, right, with stationary. Let me see. Okay, it can be polarized, it's actually stationary. 39, is stationary wave. Vibration in a straight string cannot be polarized because they are stationary wave. They are transverse and stationary. The reason being is because they can only be stretched. 40. They say vibration in a stretched string. They don't say spring or string. So like use your earpiece. If you tie your earpiece to one end of something now, as you do them like this, if you can't flip them from the other end, they go it will become something like this. Go they do like this. See the cord go they do like this. You dey see am. As they go like this, na transverse. But at the same time, notice it's attached to an end. It's attached to an end, so it's stationary. It's stationary. 40. The property that is propagated in a traveling wave is the property propagated in a traveling wave is energy. Option B. Which of the following is a characteristic of stationary wave? Stationary wave. They are formed by two identical waves traveling in opposite direction. When we started this series, I gave examples of waves. Sorry, how to identify the type of stationary wave. 42. Transverse wave can be distinguished from longitudinal wave using the characteristics. Polarization. Transverse wave can be polarized, right? Transverse wave can be polarized, but transverse waves can be polarized, but longitudinal wave cannot be polarized. 42. 43. Wave, medium propagation, wave velocity, frequency, energy. Which of the following is used in characterizing wave? 43. Wavelengths, wave velocity, and energy. And frequency. Option D. You can use it to characterize wave. 46. They should be identical. They should originate from the same source. They should be coherent. They should be monochromatic. From the statement above, the condition of the two waves to interfere is 46. The conditions for the two waves to interfere is definitely identical, coherent, when something is coherent, and they should be monochromatic. Option A. 47. The phenomenon of light bending is called diffraction. The phenomenon of light that's bending is called polarization. It's called polarization. 1 minute. Bending of wave is diffraction. The phenomenon of light bending around an obstacle is called diffraction. 47 is option D. 48 has to do with calculation. The fundamental property of a propagating wave, which depends only on the source and not on the medium of propagation, is frequency. Frequency is a fundamental property that depends on the vibrating source. Frequency is an example of the wave phenomena demonstrated here. Now is an example of diffraction. 51. Option C. 2, 3. Which of the following types of wave need a medium for propagation? Sound wave. In this case, sound wave. Option C. 54. Calculation. This one, 56, is option A. 2 pi x over lambda. 57. A wave that travels through stretched string is known as mechanical wave. 58. A transverse wave and a longitudinal wave traveling in the same direction in a medium differs essentially in their transverse wave, the one that is perpendicular to the source. Longitudinal wave, the one that is parallel to the source producing it. They differ essentially in their direction of vibration. 58 is option C, direction of vibration. 59 as calculation. 60. Which of the following wave is both transverse? Which of the following wave is both transverse and mechanical? That's 60, right? Water waves is both. 61. Which of the following is not a phenomenon of longitudinal wave? Polarization doesn't happen in longitudinal wave, only in transverse wave. The other ones have to do with calculations. Alright, that's where we'll put an end to these chapters. I was able to give a tiny note. There's a target on that, so we don't jot down too many notes that are irrelevant. If you were able to jot down this note, I'd like you to snap and send to our group for assessment. I'm going to leave the link to the group in the description box of this video. And if this is your first time joining or coming across this video and you'd like to be part of our sessions, we run classes that prepare students for their entrance examinations, both general College of Nursing entrance exam, UTME exams and also JAMB examinations. If you want to be part of the class, you make use of the link there and you could enroll. Thanks for watching, and I'll see you in the next one.